everyone. Hope you all are having an amazing day. To make your day even more interesting, Intellipaat presents a live session on AWS Terraform conducted by a cloud expert who is having more than 15 plus years of industry experience. Before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to AWS. In that, we will tell you what is AWS and why do we need it. After that, we will introduce you to AWS Terraform. And also, we have covered a hands-on demo on how to create and deploy AWS services with Terraform. Then finally, we have also covered how to crack an AWS interview very easily. So, this is the agenda of the video. Without any further delay, let's get started.
Terraform. So we'll have to understand few things before getting into Terraform. Now this is my AWS account. For example, in this case, this guy is a system administrator. And this guy is a system administrator. Okay, who's handling this environment, AWS cloud. Now what happens? He is the one who set up all infrastructures in our cloud environment. All infrastructures in our cloud environment. Like it can be, he is the one who architected the design, and that a cloud application, cloud environment consists of EC2, VPC, and other services like S3, database, RDS, etc. etc. Now here, in this case, let's consider he is working for 4 years in a company. He worked for a company. He worked for 4 years in a company. Then, if he moves out of the company or the organization, if all of these environments, whatever he has set it up, if it doesn't have any proper documentation, what will happen? A new guy, whoever is coming, will not understand what exactly it is, like how the infrastructure is being created, what is the purpose of EC2 service, how many EC2 services are there, and everything will be in a mess. And the next thing, everything is a manual task. Everything is a manual task in the sense, here if I wanted to create 5 EC2 instances, I will have to create it 5 EC2 instances manually. The same way, if I wanted to create a VPC, I will have to create it manually. And everything is a manual process in creating all of these services using a console. So whatever I'm creating it here is all through console. Again, if I wanted to create an EC2 instances, what I will have to do? Again, I'll have to go launch an EC2 instance, and again I'll have to create it. Correct? In this case, a new tool called as Terraform comes into picture. It is not a very old tool at all. It was developed in the year 2014. Okay. Now what this tool does it came up with a new concept called as infrastructure as code. Now what we do, instead of creating it manually over console, so what we do is we create it as a code and we deploy it. Now what happens, anything which you created will have a trace of the code, correct? Like whatever, if I've created 3 EC2 instances, and I'll have a code of it, like so that, and moreover what happens is it brings reusability. Like I explain you all those things, it brings in reusability. So all you do is you write code once and you use it multiple times, and moreover it brings in automation of infrastructure. And how this code is being created, so they call it as HCL language. So the whatever the code which we write to create this environment is called as HCL. It's called as HCL language. And how do we do it? How do we create it? And we will see everything step by step. Use of Terraform. Terraform is to code your infrastructure. That is as simple as that. Like instead of creating everything over console manually, so what we do is we create everything using code. And what is that code? And that code is nothing but HCL. An extension of Terraform file is called as .tf files. .tf. Like for Ansible, we save it as .yml file, right? Likewise, any Terraform script will be saved in the form of .tf files. Now, using Terraform, what are all the services we can code? There are lots and lots of services which can be coded using Terraform, like major cloud platforms like AWS, Google Cloud, Azure, IBM, and then other providers, like for example, if you wanted to manage any other softwares. In nutshell, I can show you the list of providers which Terraform supports. Now, using Terraform, what all we can create it? These many services we can code it. So if I wanted to create, for example, if I wanted to create, let's consider if I wanted to create an SQL server. Using Terraform, we can create it. For example, if I wanted to create a chef cookbooks, I can use Terraform to create it. If I wanted to create Azure Active Directory, Terraform supports. If I wanted to maintain the entire AWS cloud or Azure cloud or Google cloud, everything is done using Terraform. GitHub, GitLab. So whatever we have seen here. For example, let's consider a use case where I wanted to create a user in GitHub. Now what we do, we manually log into GitHub and then we create user and then we whatever the permission which we wanted to assign it to the user, we will be able to do it. Now using Terraform, we can do the similar setup also. See here, if I wanted to create any GitHub repository, I can create it. How we will create it, let's see. But whatever the manual task which we do using a console, which can be achieved using Terraform as well. And the main purpose of it is to code your infrastructure. How does it benefit? It benefits in such a way that we can keep track of the every resource which we configure using Terraform, and also if we wanted to reuse the code. For example, I write the code once like function, and then it can be used later everywhere wherever we wanted to. Is that clear? Now we need to understand few terms before we get into creating any services using Terraform. Those are here. The first one is resource. Resource is nothing but, for example, if I wanted to create an EC2 instance. Now, what we define? No, before resource, let me put few other things also. Providers. So providers are nothing but which one we are going to use it. For example, it can be AWS, or it can be GCP, or it can be Azure, or it can be Redis, whatever it is. So what we are going to code using Terraform. So which one it is, and the basic structure remains same, but the functionality wise it differs from providers to providers. For example, in AWS we call it as EC2 service. In GCP it is called as VM. Correct? Those terminology differs, but the core concept remains same. And the next one is resource. What is resource? Let's consider we are using AWS provider. Inside AWS provider, I wanted to create an EC2 instance. In this case, what we do, we create a resource. We create a resource. This is called as resource. Any services inside your provider is called as resource. Whatever we are trying to create is then it's called as resource. Variables. So variables are nothing but an input value which can be defined while writing our Terraform script. Output. Now, output is the resultant value. For example, using a provider, AWS, I'm creating an EC2 instance. Okay, let's consider an input value I'm giving. So, if I wanted to create an EC2 instance, what all is required? What all is required? If I wanted to create an EC2 instance, in general, over console, what all I need to give? Instance type or whatever it is. Okay. Now, what we can do is we can input these values while creating our EC2 instance. That is nothing but variable. And the next one is, for example, after creating this EC2 instance, it will come up with some values. For example, instance ID, correct? Automatically it comes up with. Then instance IP address. And these are the output values. So whatever the input values which we are giving it, from that we will get an output value. So that is called as output. Okay. Terraform plan. This Terraform plan is a command. Okay. Terraform plan is a command. In the sense, for example, I have created all of these code using all of these service, I mean all of these things. I've created a Terraform script. Now I wanted to test that script before I actually apply it. In that case, what we will do, we will run Terraform plan. So Terraform plan, what will happen is it will just do a dry run before we apply it. That is what Terraform plan. Terraform apply. So Terraform apply is a command which is used to apply all your changes. In the sense, if I wanted to create any EC2 instances, first what will I do? I will create the Terraform script. Then to test it, I will run Terraform plan. Then if everything looks good, then what we will do? We will we will then run Terraform apply. Then Terraform apply will apply all your changes in the script. Then Terraform destroy. So destroy will delete all your changes, whatever is there in your, delete all your changes. Delete all your changes. And the next one is Terraform init. Here, let's consider we are using AWS provider. Correct? We are using AWS provider. Terraform init. Now here, let's consider this is your machine from where we are running all of these scripts. Now here, all we would have done is installed Terraform into this machine. Now I wanted commands which is specifically for AWS, correct? Only then AWS related configurations will work. In that case, after writing all your code, first you will have to run Terraform init. So what it does is it initialize all modules or all the required modules which are essential to run your script. That is nothing but Terraform init, which initializes all your modules which are required to run your service. I mean, run your scripts. That is nothing but Terraform init. Then what else is required? Very important thing is TF state file. TF state file. Name itself says, in the sense, TF state file is nothing but a state file which holds all configurations of whatever you have created using using Terraform. In the sense, for example, I wrote a script where it creates one EC2 instance. Okay. Now, in the same EC2 instance, I mean the same script, what I'm doing it is I'm creating, I'm creating one more EC2 instance. Now, first one EC2 instance configuration is already added. One configuration is already added. It's already there. Correct. Now I'm adding second one. In this case, what it should do, it should not create the instance which has been already created. All it has to do is it has to create only the second one. How Terraform will know that one instance is already being created and only the second one has to be created? And in that case, Terraform state file comes into picture. So any configuration which you run, it first checks with your TF state file whether all of these configurations are matching your TF state file and with your the current configuration file which you have written. If anything is missed, then it will create the required services. So that is the function of TF state file. Cool. Now, and this is one of the most predominantly or widely used tool in DevOps industry at this point of time. Till now, if like any infrastructure related activities are handled manually, now everything is being coded, and Terraform is one of the important tool which is being used in the industry, and I would really recommend you guys to go through it. So we'll use AWS for our configuration. What is the first step? First step is to install Terraform on your machine. Now what I will do, I will use one of my EC2 instance which I've created. Okay, first what we'll do, let's install Terraform on that machine. So how do we do it? All you'll have to do is download Terraform. You will get the version of it. So all you can do is whichever version you wanted to install. If you're trying it in your local machine, you can use you can download Windows and then try it. Or if you have any Windows machine, just download accordingly. Let me download this one here. Copy and then wget. Yes. Now I've downloaded the file, and then you will see something called as this. Then what you need to do is you will have to move this file to, if it is Linux machine, move Terraform to user local bin. Then what you will have to do, check then cd space user local bin. Then once it is done, Terraform, why it is not running, Terraform to user bin. Okay, so you will have to move, just download the file, just copying it and just writing it here so that then move the file to move unzip, first unzip, second move the file to move Terraform to user bin. Once it is done, you will be able to you can check and verify with the command terraform and the latest version is this one. 12.24 is the latest version which is available. Now we are set with this. Now what is the next step? Let's consider we wanted to create an EC2 instance from this machine. In this case, what we will have to do is, now one logical question. Okay, if I wanted to manage if I wanted to manage this account, what is required? For example, if I wanted to manage this AWS account using an CLI, what is required? This is just a logical question.
Root keys.
What is required?
Keys like in order to like log in and username and password.
Exactly. Correct. Here, so what we need to do is we need a credential where we can manage the account using our Terraform or whatever it is. For that, what we will have to do first, we will have to go and create one user. If somebody is new to the cloud, so what you'll have to do is go to service, IAM, IAM. IAM is a service which is used to create your user accounts. Then go to users. Then I'm creating a user with the name Terraform. Terraform. So all it needs is just programmatic access. Right? So I'm just giving programmatic access and then click next. Here, what we'll do, we'll attach existing policies directly. We'll give administrator access so that using the Terraform account, it can do anything it wants over this account. But in real time, you will have to come up with a best practice solution where we can actually give access to the console in a better way for any programmatic access. Now let me name it name Terraform, just Terraform, and then click review, create user, and then let me download this credentials and click the close it. Now here what we are trying to do, so we are trying to create an EC2 instance using this Terraform. So what I'm doing it is I'm just going to one directory, and then what I'm doing, I'm creating one directory, mkdir, and then as Terraform. And then I'm going into that. I'm creating one more directory, mkdir. I'm creating DevOps. So in this directory only, we will have all our configurations will be in this directory. Correct. Here, what we'll have to create, we will have to create one file called as main.tf. Let me create one file here. In this, let me get into this file, insert. Now, what is the first step? If we wanted to manage, we will have to define provider and mandatory. So now, first what we will do, we will define our provider here. We will define our providers here. Version is nothing but earlier they were using 2.2 version 2. With 3 they have included so many other new services also like ECS cluster, so many other services we also included in version 3 with new features. That's it. Now what I'm doing it, I'm just doing this one. That's it. Greater than or equal to 3 and provider AWS version region. Now it is done. Now what we will have to do, we will have to download that provider into our machine. How do we do it? Which command we use that to initialize all modules? Terraform init. So now let's see. Now what it does. AMI is nothing but like, for example, AMI is nothing but like when we launch an EC2 instance, what we do. Like see, whatever we are doing it here, we are doing it there manually. Whatever we are doing it here manually, we are doing it there also. Now what we do, we select an AMI here, right? We select an AMI, right? So instead of just selecting over console, so what we do is we give an AMI ID. Every image as an ID. Every image as an ID, and that is what we are giving it here. Okay. Now, what are all the features it supports? Let's consider if I wanted to create an EC2 instance. These are the arguments which you can pass in the sense which availability zone you wanted to pass, like US East 1A or US East 1B, everything. Now at this point of time, what else is required? As mandatory, what else is required? We need key, correct? We will create key name. So these are the arguments which are being passed to the script so that we can create an EC2 instance. Now let's consider key hyphen name is nothing but I have one key which is DevOps, and tag is nothing but the name which we generally we give while creating an EC2 instance. Now name equal to, let's consider Terraform first instance. Terraform instance. Terraform instance. Now our first script is ready. Now what are we are doing? See, this AWS underscore instance is the keyword. Which resource is what which we are creating? Which resource which we are creating here? We are creating AWS instance. This is the name of the resource which we are giving it. Okay, and for this AWS instance to launch an EC2 instance, what all is required? We can pass. See, anything which is given required is mandatory. These arguments AMI and instance type is mandatory. To launch an EC2 instance, these two parameters are mandatory. Other than that, we can customize all other configurations. All other configurations we can customize it. Now, till here we are done. A resource AWS instance Terraform, AMI we have given, instance type we have given, key name we have given, and then we have given a name for this EC2 instance. What is the next step? We will have to Terraform.
Just a quick info, guys. Test your knowledge of Terraform by answering this question. Which type of language is Terraform? A. Objective. B. Declarative. C. Descriptive. D. Functional. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I already have a key. I already have created a key with the name DevOps. So now what it will do, the new instance whatever we are creating will be associated with this pin key, correct? I already have a private key of this key pair. Then I can log into that machine, correct? So why do we do Terraform plan? So we run Terraform plan to check whether all our configurations are done properly or not. Let's do it here. Now here, see, it is asking in which region we will have to configure it. You remember? So while configuring providers, there was one option here, region, correct? Which I have deleted it. Region. Now here you can define your default region. US East-1 is Virginia. I have defined it here. Now if I run Terraform plan, now let's run Terraform plan. See, the main thing is if there are any issues with your configuration, when you run Terraform plan, it shows the error. Whatever error you have it in your configuration, it will show it. After fixing it, again, what you can do is you can run Terraform plan. So let me change it. Main.df access key, access key, access underscore key, then key underscore. Now what will I do? Terraform. Now what it says? It says new mission will be launched. So this will be the configuration. Now what will I do? So how will I create a new mission here? I mean, if I want to apply these changes, what will I do? What will I have to do? Terraform apply. Now you will have to give yes. The moment you give yes, it says error. No subnets found for the default VPC. Please specify the subnet. Now what happens is, since whatever we have given it here, it tries to launch it on the default subnet. Now what I've done, I've deleted my default subnet. I've deleted, when you look at here VPC, see here I've deleted the default subnet and I've created my own subnet. With that configuration, what it does is, so whatever we have done here, it tries to create this EC2 instance in the default subnet. Now that is what we got an error. See, for launching source instance missing no subnets for the default VPC. Please specify the subnet. Now what we will do? We will go configure main.tf, then include one more configuration, which is nothing but subnet. Let's check whether it is right. Subnet underscore ID. That is the argument which we will have to pass. And this is the subnet ID. Now, again, what we will have to do after making changes, Terraform plan. Okay, now if you look at here, it will say that subnet ID is this one. Correct? Earlier, when you look at, you would have not seen that. Now, Terraform apply. Cool. Now we can see that one resource is added. Let me go to my EC2 instance. Earlier it was one instance running. Now it is two instances. Second instance, this instance is running here. And whatever configuration which we have given, it has come up. Now you can see one thing here. It did not have any public IP address. Correct? It did not have any public IP address. Now in this case, what we can do, what is required if I wanted to connect to this machine, a public IP address is required. Correct? Now let's create a public IP address for this machine and then attach it to it. Now in this case, Terraform apply is already done. Earlier you will not see one file called as terraform.tf state. After you apply your first change, this file will get created, terraform.state file. What is the purpose of this terraform.state file? It maintains all the information about your configuration. This is your instance ID. See, this is your instance ID. The state file maintains all information about the resources which are configured using Terraform. Now let's see. Now what is our second requirement? If we wanted to attach any public IP address to that machine. Of this machine. Okay. Now in this case, what we wanted to do, if I wanted to create a public IP, there is a resource called as AWS EIP. Correct? There is a resource called as AWS EIP. Just go there. Here, what will I do? Create and so this. Now what we are doing here, we are creating one more resource, which is nothing but AWS EIP, and let's name it as Terraform instance AIP. Now, this is nothing but getting a value of, this is how we get value of other machine. So whatever we got it here, see the whatever we are getting it here, the what is this syntax is the older version syntax. Here we actually we don't need that. This all of these things are not required. Now what I need, to which machine we are attaching this elastic IP? To this machine, correct? And what is the resource name? Which is AWS underscore instance. And what is the name of the resource? What is the name of the resource? Which is Terraform. It is Terraform. And ID, to understand that, we will have to understand a bit about what are all the values it results. Let's consider, where is it? EC2 instance, AWS instance. See, attribute reference is nothing but what are all the values it can result. In the sense, see, what are all the values you get it in your TF state file. Terraform.tf state file. Here, what is that? ID, correct? See, this value it results from this configuration. What is that configuration? This value holds this machine. Now what we are doing it, in this configuration, I'm creating one more service which is nothing but EIP, and this will after creating that elastic IP, it has to be attached to this EC2 machine. How do I know that to which EC2 machine I will have to attach? Using this configuration value, AWS instance.terraform.id. This ID actually holds what? The value of that machine, which is nothing but this one. This actually, this one, the value, this one, let's consider if I run this value, what will happen? Terraform plan. See what happens. It creates an EAP and then attaches and gets attached to that EC2 instance. Same way, what will happen? Let's see if I give that value. I'm replacing it with. So these are dynamic values which we can get it. How do we get it? AWS underscore instance underscore dot terraform dot id. Now again, if I run terraform plan, see, we got the same value. Now let me apply it. Terraform apply. Ask for check, select yes. Now you don't see that public IP, any public IP is being attached here. Now if I refresh it here, see, one IP got attached to it. And this is how it works. Now, using the same concept, what we can do is we can create any number of services which AWS provides with bit of fine tuning that is required. That is required according to a configuration, the best practices which we follow and everything. Now, see, it becomes more effective or more powerful as and when it goes, like when we start talking about other configurations. You'll understand the actual purpose of it. Now let's talk about something called as variables. Now the same concept is same. Variable is nothing but if you wanted to input any variable, then we use concept called as variable. Correct? If you wanted to pass any, if you wanted to pass any values from the user or get values from the user, then we define variable. And how do we do it? There are multiple ways to do it. One, what you can do is you can create a file called as variables.tf, whatever it can be. I'll give it as inputs.tf. inputs.df. You can create the same method also. I created with the name inputs.df. So what we can do is, let me get some values from the user. Why do we have to give this value automatically here? If I give, everybody can use it, right? So what we can do is, we can define it as a variable so that it doesn't being exposed. Now what I will do, I will define it in such a way that give var dot access underscore key and then var dot secret underscore key. So in this case, after defining it here, so go to inputs.df file. We will have to define that variable. So how do I define that variable? Key name is variable and give the name variable. Let's, what is the name I'm giving? Access underscore key. Then open bracket and then go close bracket, and then name is, we will have to define which variable type it is. Now what variable type it is? That is string. And there are different types of variables also, like list of string, maps of string, tuple of string, lots of other things are also there. This point of time, let's not get into that level. So the value which we require there is string. And how do we do it? Type equal to string. That's it. The same way, we have one more variable also, secret underscore key, type equal to string, and then close it. Now with this, what happens? Now let me check the configuration, whatever I've done, Terraform plan. See, now here it asks for the value. What is the value? var.access key, which I will have to give it from, and then secret value.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
What is infrastructure as a code? So guys, infrastructure as a code basically means that instead of going to the management console of your cloud provider, let's say you're working on AWS, right? Now, if you have to launch a server, you will have to go to the management console. Then you will have to click at 20 different places to do the configurations, and finally you will be able to run it, right? Now, this is okay if you're doing it for just one time, but imagine a company where probably you are deploying thousands or 2000s of servers or services in a particular cloud platform. All right. So, and let's say you want one day a requirement comes in that you just have to create a replica of it for some work, or let's say you requirement comes in that um the servers that you're running, you have to upgrade all their hard disks to a certain size, right? Or let's say it just so happens that you want to upgrade the specs, the CPU and the RAM of your systems altogether for all your thousand servers. So how will you do it? So when you're managing an infrastructure at a large scale, it makes more sense to manage it by code, right? Because when you're writing code, all you have to do is you have to run that code, and those changes will be replicated across all of your infrastructure. So that is what basically led to the formulation of infrastructure as a code domain. And in infrastructure as a code domain, you will find a lot of services which supports it. So when you talk about, for example, AWS has a service of its own which is called AWS Cloud Formation. So using the AWS Cloud Formation service, you can do all the tasks that I just told you. right? With a single click of a button. It's just that you will have to write the code first, and only then you will be able to do it, right? Now, there are multiple tools in the market which can do it. The most powerful, I'll not say powerful, the most popular tool in the market right now, it's Terraform. Why? Because I told you that Terraform can basically be applied to any of the providers which are out there. So if you learn cloud formation, it will only be limited to deploying resources on AWS. But if you learn Terraform, if you understand the basics of Terraform, you can apply it not only to AWS, also to Azure, also to GCP, without switching any tool. Okay, that's why people are more pushing towards learning Terraform. Companies are more pushing towards their DevOps engineers to have the skill of knowing of working with Terraform, right? So we'll reach Terraform later, but right now this is what infrastructure as a code is. That is, when you manage infrastructure not using the management console, but by writing code, and whatever resources you want to deploy, whatever specifications you want for your resources, all that is mentioned in the code. So that's what infrastructure as a code is. Moving forward, now let's understand what is the difference. Now, this is where people get confused. So people who probably are from DevOps background, they might find some similarities between infrastructure as a code and configuration management. So what are the things in common, and what are the differences between infrastructure as code versus configuration management? Okay, so guys, infrastructure as a code basically helps you to create or destroy hardware architectures, which basically means, let's say you have 100 EC2 servers. On those 100 EC2 servers, you have basically created a VPC inside, or a network. Inside that network, you have those 100 servers deployed. Along with those 100 servers, you've also connected a database, right? Along with that database, you also have a NAT gateway through which people through which your resources, that is your servers and database, are able to access the internet, but the outside internet is not able to access them. So these are some of the resources that you can create or destroy using the infrastructure as a code service. But when you talk about configuration management is limited to deploying software. So let's say you have a fleet of hundreds of thousands of servers, and on all those servers you want to do a software upgrade. Let's say on all those servers you have a certain JDK installed, and now you want JDK 10 or you want JDK 11 to be upgraded on all those servers. So when you have this kind of a requirement, you use configuration management tools, which helps you to change the software components of large scale architectures. But let's say you want to change the hardware specifications of your architecture. In those kind of scenarios, you will be using infrastructure as a code, right? Now, one very peculiar thing about infrastructure as a code is that it can also help you install some software. Now, this might create an ambiguity in your mind that if infrastructure as a code can also install softwares inside a particular, inside a particular architecture, why do we need configuration management? Why don't we install the softwares using infrastructure as a code as well? Right? So it can only install softwares which are required while you create the server. Let's say when you're creating the server, you want Java to be installed on all those servers. Okay, so that Terraform can do for you. But let's say tomorrow you want, now on the existing architectures or on the existing servers, you want to upgrade the Java version, that infrastructure as a code cannot do for you. So that only configuration management could do for you. So without touching, these servers, without creating or without deleting the resources that you have, if you want to change the configuration of a particular hardware, the software configuration of a particular hardware, only the configuration management tool can help you in that, and not infrastructure as a code, right? Third thing is, this is basically just a warning that infrastructure as a code should not be used as a replacement to CM tools. And similarly, configuration management tool cannot be used as a replacement to IAC tool. So configuration management does not give you the option of managing your hardware. Infrastructure as a code does, but the feature that it gives you of managing the software is only possible while creating a hardware, while changing uh, something on the server. If you want something to be remain if you want something to be there as it is, and at that time you want to run a particular script on that server, that is not possible. You will have to destroy that server, recreate it, and only then that script can be run, in case you're dealing with infrastructure as a code. Okay, so guys, these were the differences between infrastructure as a code and configuration management. So guys, now let's move on to the next topic, which is basically what is Terraform. So now what we have understood right now is what is infrastructure as a code. So we understood that infrastructure as a code. So I was saying that now that we have discussed, what infrastructure as a code is, we have discussed what configuration management is. Now let's go ahead and understand what Terraform is. Okay, so guys, Terraform is basically it's an open source infrastructure as a code software tool, which was developed by a company called HashiCorp. All right, so HashiCorp is a company which basically developed this tool, and it basically helps, or it enables the people who are using the software to create architectures for a particular data center or inside a data center, and also provision it meaning bootstrapping it, right? And it can be done using high level configuration language known as HashiCorp configuration language, but it is basically JSON what we are using. And if for those of you who do not understand what JSON is, we'll just have a look at what it is, and it's very simple to understand. There's no syntax that you have to understand. There are well defined keywords that you again have to don't learn. You can just mention, refer the documentation, and that'll help you out with understanding how basically infrastructure as a code basically works. Okay, so with that said, this is what Terraform is, guys. Moving forward, now let's understand how we can install Terraform for any particular cloud provider, and today the example is AWS. Okay, and the Terraform installation is a very straightforward process. It's very easy. So we are going to go ahead and now understand how basically it works. Okay, so what we're going to do is, guys, we're going to quickly go to our AWS management console, right? Or let me first go to the Terraform official website, and from there we'll understand how we can download it basically. Okay, so let's just type in Terraform download, and the first link that you will get is basically the Terraform software link. So let's check if Terraform. So you can check the compatibility of Terraform with private cloud softwares for OpenStack. Yes, so Terraform is compatible with OpenStack. So let's say if you have configured your private cloud to work with OpenStack, then Terraform can control it, right? So yes, Terraform can be used with private clouds as well. Given so you have to understand that anything that basically Terraform works with basically is called a provider, right? So in providers, you can see all these providers are compatible with Terraform. So right from Acme, which I guess is again yet another cloud platform, to GitLab, and then you will also find Docker over here. So it's also compatible with Docker. If we search, do a control F for AWS, it is compatible with AWS, it is compatible with Azure, it is compatible even with Azure DevOps services, right? Then if you search for GCP, Google Cloud, it's also compatible with Google Cloud as well. And let's search for DigitalOcean as well, because that is also, yes, so it is compatible even with DigitalOcean. So since it's an open source project, That's why a lot of companies have now started to roll out libraries through which Terraform can interact with their cloud vendors, right? So that is what that is what basically we are trying to understand over here. All right. Okay, coming back. So now let's start by downloading Terraform first, right? And once Terraform is downloaded, you can use it for any of these providers that are mentioned on this list. So how to configure it is something that we will also see. But first, these are the platforms that your Terraform is available for, right? So Terraform is available for Windows, it is available for Mac, it is available for Linux, for FreeBSD platforms, OpenBSD platforms, and even for Solaris. Okay, so on any of these platforms, you can install Terraform. I know a lot of people are from Windows platforms, so if you want to install Terraform, it will basically download as a zip to you, and this will also have an exe inside, which you will have to see how you can basically configure. So for Windows, I think there's also an absolutely awesome Terraform learning platform that they have given over here that you can actually learn from, right? So you can go ahead with this and you can learn how to use Terraform as well. Let me give you this link as well. And for anything other than this session, if you want to learn about Terraform, you can learn from here. Apart from that, installing Terraform, I think this is a link which will show you how you can install it on Mac OS and Linux distribution. Right, with Windows, you will have a setup which you can download, and that will help you, get started with Terraform. It will automatically install a command line tool for you, and you'd be set. For Linux and Mac, it's a little more elaborated. So let me just show how this works. Okay. So first thing, what you'll have to do is you will reach this download page, right? And depending on which platform you are going to use it on, for example, let's assume I'm going to use it on an Ubuntu system. So what I'll do is I just go to a certain region. Let me go to Ohio. And in Ohio, now what I do is I'll just deploy an EC2 resource, right? Let me install a Linux machine over here. So let's go ahead and launch an instance. Now, which instance which I'll be launching, which operating system? I'll be launching a Linux operating system. So let me choose Ubuntu over here. Okay. So 2.micro option, which is free tier eligible. So I'll be choosing that. And I just need one instance. The rest everything I can leave it at default. Let me choose the default security group. And now let's go ahead and launch it. Okay. So with this, I am now basically launching an AWS server on which I will be installing Terraform. So this server is just like your own system. If you have Linux or Mac operating system, this will show you how you can basically go ahead and install.
Just a quick info, guys. Test your knowledge of Terraform by answering this question. Which type of language is Terraform? A. Objective. B. Declarative. C. Descriptive. D. Functional. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So now that Terraform is running, guys, what I'll do is let me just connect. Sorry, this server is running. So what I'll do is I'll just connect to this server. So let me open a terminal and let me connect to this server. So for those of you who do not know how to deploy a server, how to connect to it, I'll give you a very short crash course just now. Okay, I'm connected to the server. So for those of you who do not understand how to connect to a server, etc., well, when you're launching an instance, so first of all, you need an AWS account. Okay, so once you have an AWS account, then what you have to do is you will be have to. So this is the landing page that you would be coming on. So this is where you will land up. Okay, so the first thing that you will do is you will click on EC2 right over here. So this is basically the server service This is a service which is basically going to give you a virtual server on cloud. Then you have to click on running instances. And on running instances, you will have to click on launch instance. Okay. So once you click on launch instance, then it will basically, ask you what kind of operating system do you want on the server. So you can select any of these operating systems. I chose Ubuntu operating system because that's the most user-friendly operating system that you can work with, right? So you can select it from here. Next thing that it's going to ask you is how much of RAM and how much of CPU do you want in your server, right? So I chose the T2.micro because once you sign up on AWS, you also get some, free minutes or free hours for your server to run with, right? So this particular server is free to run up to 750 hours in a month. So this is what you will be choosing, and this is enough. 1 GB RAM and 1 core CPU is enough for doing all the hands-on that I'll be showing you, right? So you would be choosing this, and then you will be clicking on next. On this screen, if you do not understand AWS, it's okay. You can leave everything at default. You can just straight away go ahead and click on next. Again, click on next. This is basically going to tell you how much of hard disk space the AWS is giving you. So you can just click on next. Here again, you can just click on next. You don't have to do anything over here. Then here it is basically configuring a firewall for you, right? So automatically a rule will be added for you. You don't have to do anything over here. Just click on review and launch. And finally on this screen, this is the most important screen, guys. So on this screen, what you will get is you will get the option of you reviewing whatever you have specified, right? So if everything looks good to you, good to go, just click on launch. So once you click on launch, you will get the screen where basically, so when you work on a system in your office or on your personal system, you basically get authenticated using the username and password, right? So when you're authentic or when you're creating a server on AWS, it's a different option, and that option is basically a file using which you authenticate yourself or authorize yourself into the server. Okay, so that file basically has to be created. So in case this is the first time you're logging into AWS, or in case this is the first time that you're creating a server, what you have to do is you have to create a new key pair. Then you have to specify that name of the file. So let's say the file is Terraform, just for example, and then you have to download this file on your system. Okay, so this file will now be downloaded to your system, and this is the file you will use to authenticate yourself into the server. Okay, so once this file is downloaded, just click on launch instance, and this will launch your server now. Now comes the point of connecting to your server. So how can you connect? So once your server is deployed, you can again come back to your EC2 page, and over here you will see the option of running instances. Okay, so running instances basically is the number of the server that you're running. So in my case, I launched this server. In your case, you will see one server which is running. You can change the name by clicking on this edit button and adding the name over here, right? So once the name has been added, the next thing that you can do is just select the server and now just scroll down. So you will find something called as public IP over here. So this is public IP with which is basically going to will help you to connect with your server. So this is the IP of your server, you can say in a brief manner. So now using this IP, you can connect to your server. And if you're on a Linux system or if you're on a Mac, all you have to do is you have to go to your terminal and you can use to connect to it. So I think people on Mac or terminal, they already would be knowing how to do it. If you do not know, just let me know in the chat. For people on Windows, what you'll have to do is you will have to download a tool called Putty. So just go to putty.org, or what you can do is on Google, you can type on download Putty, right? And you will get these links, right? So click on the first link and you will reach this page. Now on this page, you will have to download this Putty software. Okay, so how can you download it? You can click on, you can download Putty here. Just click over here and then it'll give you a file list like this, right? So download the 64-bit version for your system. Okay. So once you download this, the tool will be installed and you are ready to use it. After that, there's one more tool that you have to download, and that download tool is PuttyGen. So you'll be downloading two tools. One is Putty, the other is PuttyGen. Now let me give you the logic why you're downloading two tools. So the first tool is going to help you connect to your server, okay? And the second tool is basically going to help you use this PEM file which you have downloaded, which is going to help you authenticate in your to your remote server. Okay. So how will the Putty tool look like? Let me show you some screenshots. So once you open the Putty tool on your Windows system, it's going to look something like this. Okay. So this is where your public IP address will go. This IP address of your server, this will go in this particular text box. Okay. And then what you have to do is you have to double click on SSH, which is this particular button. And once you have double clicked on SSH, then this kind of a window will open, and then you have to click on auth. Okay. So once you have clicked on auth, the next thing you'll be doing is, this is the screen that you will get. So once you click on auth, you will get this browse button. Just click on this browse button and then go to the file that you have downloaded. That is a PEM file. Okay. Now Putty, this tool, it basically does not understand the PEM file. So this is where you will basically make use of the second software that you downloaded, which is PuttyGen. So this tool only understands the PPK format. It does not understand the PEM format that you have downloaded. So what you need to do is you need to convert this PEM file into a PPK, right? So how can you do that? So you will basically now go to the PuttyGen tool. Just open that. Okay. So what you'll have to do is, this is how your tool will look like, your PuttyGen tool. You will have to click on load. Okay. And once you've clicked on load, you will basically have to now go to the PEM file that you have downloaded earlier. Once you select the PEM file, these two buttons will get highlighted. Okay. So, and it will get highlighted like, 1 second, I'll just show you. Okay. It will get highlighted like this. So once you click on load, you select the PEM file, it will get highlighted like this. And what you have to do is you have to click on save private key. And that is it. So once you click on save private key, it will basically give you a prompt. Do you want to save it without a password? So you just click on yes. And now in the same location where you have this PEM file, a PPK will basically be downloaded. And once you have that PPK, just come back to your Putty tool, click on browse, select that PPK and click on open. Okay. So once you click on open, then it will ask you for the username. So the username, when you have deployed your server as an Ubuntu operating system, the username would be Ubuntu. Hit enter, and that's it. It will not ask you for any password. And once you are on this, the next steps I'm going to tell you. Okay, guys, great. Now that we now know how to reach to the server, what we'll do now is let's understand how to install Terraform on it. Okay. So now we are on a server which is installed on AWS, and it's a Linux server. So what we'll do is we'll follow the installation instruction for installing Terraform on Linux. Okay. So what you have to do is just copy the 64-bit link, come to your server, and here you have to type in curl -O and then the link that you just copied. Hit enter, and this has successfully downloaded Terraform on your system. It's around 18 MB. Okay, so you can do an ls over here to check. This is the Terraform tool that you have just downloaded. And now what you have to do is you have to unzip this Terraform tool. So if you type in unzip, you can see it's not installed on the server. So all you have to do is type in sudo apt get install unzip. So unzip is now installed on this machine, and now what you can do is type in unzip space download it. Okay, hit enter, and this will unzip your zip file, and this is the folder that you get, the Terraform folder. Okay, and now this Terraform folder, it just has to be copied to a location called user local bin. Okay, so just copy it over there, and then Terraform is installed completely. So how can you check Terraform is installed? Just type in Terraform -- version. You can see right now Terraform is not installed. So what you can now do is copy folder which you have unzipped and copy it where? Copy it to user local and then bin. Okay, so you will need the sudo command along with this. Let's enter sudo, and has been moved to user local bin. So as you can see, only the zip file is present. So you can just remove the zip file now, no longer needed. And when I type in Terraform version, you can see it now returns with the version of Terraform. So with this, the Terraform tool is now installed on your system, and that is about it. That is all you need to install Terraform on any Linux machine. Okay, if you're working with Windows, you just download the setup that I told you, and that is about it. If you're using Mac, again, same thing, just copy this folder, copy it to user local bin, and that's about it. Okay, and then you will be able to use it. Okay, so Benga saying, can Terraform be used with Linux as well? Well, that is exactly what I've done, Benga. So this is a Linux machine on AWS where I've just installed Terraform. All right, guys. So now that Terraform, we now know how to install Terraform on different operating systems. Now let's come down to using Terraform, how we can use it. Okay. So create a user and use this user to authenticate Terraform to AWS. This and system. So let me show you guys. So as you can see, Terraform is installed on my machine, and it says that a Terraform version of Terraform is out of date. The latest version is 1.29. So it's a minor release which they have made, which I think is not going to change anything. So we're going to stick to the version that I have. Okay. Nathan is saying that I've enrolled in Big Data and Data Science Architect course, and AWS is my self-paced course. Is it same? Yes, Nathan, that would be the same. Okay, great. So now, guys, now let's go ahead and start by let me tell you how you can work with Terraform. So first thing that you need to do is you need to create a new folder. Okay, so let's create a folder. Let's call it demo_Terraform, right? And now inside this folder, let's go inside this folder. So even in Windows, you can start by creating a new folder and then go inside that folder from your command line. Okay. Now, once you're in your command line, let me just make it a little bigger for you guys. Okay, this now should be visible to everyone. Okay, so now that you are in your command line, what I'll also do is I will use an IDE like Sublime, and let me open the folder. Okay, so inside this folder, you will have to initialize Terraform. How do you initialize Terraform? That I'm going to show you. So guys, first things first, you will first have to initialize Terraform on the terminal, right? So how can you initialize this? Just type in Terraform in it. And mind you guys, I'm inside my folder and then I'm initializing Terraform. Okay, so just hit enter. So it now says Terraform has been initialized in an empty directory. Okay, so when you initialize it, it's necessary to also mention the cloud provider that you're going to work with. How can you mention that? So first, create a file in your folder and call that file as main.tf. TF is the extension for Terraform files, and main is the name of file that I'm giving right now. Okay, so create a file called main.tf, and in main.tf, now enter this syntax, which is going to be provider. Then in quotes, specifying the cloud that you're going to work with. So I'm going to work with AWS, right? And let us deploy all resources in a certain region. So which region can we deploy our resources in? So I think we are in Ohio right now. So all you have to do now is go back to your AWS management console, and now you just have to select the region that you want to work in. So let's say I want to work in Oregon region. So let's go to Oregon. So now it's switching the console to the Oregon region. Seems the AWS site is a little slow, so please bear with me. Okay, so I'm inside the Oregon region now, and what we are going to do is just check the code that is in front of the region that you are in. For example, it's US hyphen west hyphen 2. This is the region code of the region that you want to deploy resources in. Okay, so you have to mention this region name in your code. So what you'll say, you will type in region equals to, and then you will type in the name, the code of the region, which in our case is US hyphen west hyphen 2. Okay, that's about it. And then you will have to enter two more things, and I will be telling you those things in a little while. But first, you have told Terraform that you want to work with AWS, and you want to work in the region US hyphen west hyphen 2. So just save this file, and now what you have to do is just come back to your terminal, right, and type in Terraform in it again. So now you can see it is checking for available provider plugins, downloading plugin for provider AWS. So now it is downloading all the plugins for the AWS cloud provider into the folder that you're working with. And once it has initialized it successfully, you can see Terraform has been successfully initialized. So now Terraform, the one that you have basically right now installed, it now knows how to talk to AWS cloud. Okay, but what it doesn't know as of now is how to talk to your particular account, right? It knows it wants to talk to AWS, it knows it has to talk to the Oregon region, but what it doesn't know is what is your user account and password. So when you want to specify your user account and password in Terraform, you do not use the username and password. What you use is something called as secret key and access key. Okay, and how can you get that in AWS? Just go to your AWS management console and open a service called IAM. So just click on this AWS icon over here. You will come back to the dashboard, and now just search for the service called IAM. Go inside the service, and inside the service you will have to create a user. So let's click on this user. So let's create a user. Let's call it Terraform. Now what this user wants is programmatic access. So check on this. So this programmatic access, as you can see, it's going to give you an access key ID and a secret access key. And that is what we need in order for authenticating Terraform to your account. So click on next. And now you would want to give it administrator access. So how can you give it administrator access? Just click on attach existing policies. And here the first policy that you would see is administrator access. Just select this, click on next, click on review, and click on create user. Now, when you're working in production, guys, obviously you will not be giving it administrator access. You will have to learn AWS in a more detailed manner, and then you will understand that how to set boundaries to a particular user, what kind of services it can touch, what it cannot, and accordingly you will be setting the permissions for your user. But since we are not learning AWS today, we are learning Terraform. I've just given all access to this particular user. Now I will be copying the access key ID into my code, and I will also be copying the secret access key, which is this. Don't worry, after this session, I will be deleting this user. So you don't have to worry about me exposing this credentials. And then you will have to enter so whenever you're defining anything in Terraform, the first keyword that you have, it should not be enclosed in braces, or it should not be enclosed in inverted commas. It should just be written like this, and whatever value you are entering, that should be entered in inverted commas. So these have to be inside inverted commas. Okay, and then here you will be specifying access underscore key. Okay, one second. So access underscore key, and this would be your secret underscore access underscore key. Secret underscore access underscore key. Now let's say you're not sure of what keyword you have entered over here, so you can always recheck it in the documentation. So Terraform has very awesome documentation to follow. So what you can do is just go to terraform.io, and once you're on it, just click on docs and click on Terraform CLI. Okay, or actually not here. You have to actually go on tutorials. So in tutorials, then what you will be doing is you will be finding a lot of topics over here. So right now what we are doing is we are basically building infrastructure. So the first topic is in this is configuring with AWS. And right now I just want to see what is going to be the syntax for the access key and the secret access key. So let's say you're not able to find anything in the documentation. What you can also do is just search for it. So access underscore key Terraform code. Okay, so here it is. It's AWS underscore IAM underscore access underscore key. Okay, AWS underscore IAM underscore access underscore key. And similarly, you will have the secret as well for this. So secret key AWS Terraform. So this is the variable for that. So let's mention over here like this, and let's mention over here okay. So with this, now I think your provider is configured. How can you check if this is going to work for you? Let's verify. So now let's verify if this is working for us. So what I can do is we can start by creating an EC2 instance by using this Terraform code. So how can you create an EC2 instance? Just type in resource, right? And if you're using an IDE like Sublime, it can also give you suggestions, but I'm not going to use the suggestions for now. And what kind of resource that do I want to deploy in AWS? I want to deploy AWS underscore instance. Okay, and then I will be specifying an identifier for this resource. Let's call this example. And now let's specify this resource by putting it in braces. Okay, so the first thing that you specify when you are creating an EC2 resource is you specify an AMI. Okay, and in AMI you basically specify the AMI ID. And how do I know we need an AMI? Well, it's very simple. Like I said, just go to the documentation from Terraform, and here you can see this is the code for creating an EC2 instance. So first you have to specify AMI. This is the AMI ID. How will you get the AMI ID? Go back to your management console, click on launch instance. So the first thing that you have to choose is the operating system, right? So that operating system is basically called AMI, meaning Amazon Machine Image. So whichever operating system you want to deploy, just copy the AMI ID for it. So let's say this is what I want. I want to deploy an Ubuntu instance. So I'll just copy this AMI ID, come back to my code and put the AMI ID over here. Okay. Next thing that I will be specifying is the type of resource that I want to launch, right? So is it going to be a 1 GB machine, or it's going to be a 2 GB RAM machine? So that is something which is called as type. Okay. So you can see that there are various configurations over here, and every configuration has a name attached to it. So if I want a 1 GB RAM and a 1 GB core CPU, the type is called t2.micro.
Just a quick info, guys. Test your knowledge of Terraform by answering this question. Which type of language is Terraform? A. Objective. B. Declarative. C. Descriptive. D. Functional. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
4 GB RAM and 2 core CPU, it is called t2.medium. So based on what type I want to deploy, I will have to specify in my code. So let's say the type is t2.micro. Okay. So this is the AMI ID. This is the type that I want to deploy. And now what I do is I just go ahead and create it. So let me just change one small thing over here. This will be called access key, and this will be called secret key. Okay. And this is the resource that I want to launch. So we'll just save this. And now let me show you how you can deploy it. Okay. So now what I'll do is I will, let me just come back to my slides first, and then I will show you. So there are 4 basic operations in Terraform. First is init, which I've already showed you. So that init operation basically downloads any dependencies which might be there for working with your code, right? For example, I wanted to work with AWS. So in my file, I specify that I want the provider as AWS, and then I did init. So what I did, it download all the dependencies for working with AWS cloud. The next operation that you work with is plan. Okay. So now that I've written the code, I can ask Terraform the plan. So what is the plan that it is going to work with? So I'm just going to type in Terraform plan. And now it will show me what all things Terraform will be creating for me with the code that I've written, that is over here. So I've just told Terraform that I want an AWS instance to be created with this AMI ID and this size. And other things which are required by Terraform, for example, uh, what size of hard disk to be attached to it, etc. It's gonna take it as what do you say? It's gonna take it as default. Now, whenever you have any errors in your code, is basically going to show over here. For example, it says in line 7 resource AWS instance example, resource AWS underscore instance example, the argument instance underscore type is required. And then it give me one more error that there is an unsupported argument that I've entered, which is type. So this is clearly telling me that in line 10, I have to specify instance underscore type instead of just type, because type it's not able to understand. So what I'll do is I'll just simply copy this.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Come back to my code, replace type with instance underscore type, save this code, and again go back to my terminal, again type in Terraform plant. So now it's reading my code, it's understanding what has to be done. It's also taking in some default values which I did not enter. So Terraform only asks you values which are required. There are some values that if you don't enter, it will take it as default. Okay. So this is the plan that Terraform has given me, that this is what it is going to deploy in my AWS machine or AWS account. So it's saying the AMI that Terraform is basically going to use is this AMI ID, right? The other thing that says it can only be known once it applies it. The instance type that it is going to deploy is t2.micro, and other it's saying it can only be known after creating it. Okay, so here one thing to understand is when you see this icon which is plus over here. So plus, whenever you see plus in your Terraform plan, that basically means it's going to create. When you see anything such as minus, that means it's going to delete. And when you see, another sign, so I'm going to show you that sign in a little while. It's called a sine curve sign, or there is another term to it. I'm not remembering it right now, or escape sign if I'm not wrong. It basically tells you that it's going to modify. Okay. So now once you verify, okay, so these are the settings that it's going to do for my Terraform infrastructure. Now what I can do is I can type in Terraform apply. Why Terraform apply? Because that's the third operation that you have to do. So first you initialize it, then you plan it, and then you apply it. If everything looks good to you in the plan, you apply it. So once I click on Terraform apply, but before you do that, let me just come back to my EC2 console, and let me show you that right now there's nothing created inside it. So if I go to running instances, there is no instance which is created over here as of yet, right? And now what I'll do is I'll just click on Terraform apply. Now it will take a moment, and it will first go through the plan, and then it will ask me whether you want to go ahead with this plan or not. So you have to enter yes, hit enter, and now it will start creating all these resources for you in your AWS account. Okay, so as you can see, it's creating. It will take some moments, probably it will take 20 to 30 seconds, and then it will create the architecture which you have specified. Okay, so right now we are just creating a very basic architecture. I just told it that I need a server of the type Ubuntu. That's it. Slowly and gradually, as we progress along this session, I will be showing you how you can do even better things than this. Okay. So meanwhile, if you have any questions, please let me know. Okay, Vaibhav was saying, is it good to learn Python to get good opportunity in AWS? Well, Vaibhav, yeah, I mean, any programming language will work. So if you're starting to learn any programming language, yeah, Python would be a good start. And how to get AWS free access? Well, Vaibhav, the first time, all you have to do is sign up on AWS. So once you sign up on AWS, you automatically get signed up for the free tier that we are using. So the only limitation is free tier we can only give you 1 GB RAM and 1 core CPU. That is T2.micro server free. No other server will be free. Okay. So as you can see now, it says apply complete resources. So one resource has been added, 0 has been changed, and 0 has been destroyed. So if I go back to my management console, if I hit refresh, you can see that automatically a server has been created for me now, right? And this server, basically, if you see the key, there is no key specified over here because obviously we did not specify the key. So as and when we will be moving along, we will be changing all these settings as well, right? So everything is default. The only thing is it is the instance type that we mentioned is T2.micro, right? And the operating system that it basically deployed is Ubuntu. All right. And this is how you create a resource using Terraform in AWS. Alok Benga is saying, what is the major difference between CloudFormation and Terraform? Well, like I said, Alok Benga, in the starting of the session as well, CloudFormation is a very specific service just for AWS. But when you talk about Terraform, it can be used with any cloud provider. So if you learn the Terraform tool, you're not only restricted to working with AWS, you can work with any tool. But if you learn CloudFormation, you can only work with AWS, no other tool. Ranjit is saying YAML and JSON both languages need to learn for Terraform. No, so only JSON is enough, and there's nothing to learn, Ranjit, in this. So as you can see, this syntax is very straightforward. First, you specify what you want to deploy. So I wanted to deploy a resource. Then you specify what type of resource I wanted to deploy an AWS underscore instance. Then you give a name to this resource. So I given it example. Then all the arguments that are required for this instance to be deployed, I mentioned that. Then equal to, and then the value of that resource or that argument. That is it. So Arvind is saying, what about the name of the instance? So Arvind, we will be coming to that in a little while. Ranjit is saying we can also do VPC setup and pod related configuration Terraform. Yes, Ranjit, you can do it. So any resource in AWS you can create using Terraform. No resource is left behind. Any resource, whether it be Elastic IP, whether it be VPCs, whether it be databases, everything can be created using Terraform. So Alok Banga is saying, can you please show again how you link Terraform to AWS console? Well, all I did was I created an IAM user, Alok Banga. So once I created that IAM user, I got this access key and secret access key. We just mentioned that over here in the provider section of your code, and that is it. That's how you connect to your AWS management console. That's it. So probably if you want an in-detail discussion, you can go through this video again once you get it. Monty saying same on Azure also. Yes, Monty. The process is going to be the same. Only the argument names might change. For example, when you're using Azure, there's nothing called an AMI in Azure. So this AMI might have a different keyword. But yes, the resource block will have to be created. The resource type will have to be specified. Provider has to be specified. Region has to be specified. So all these things will be the same. Ranjit is saying use cases of Terraform, please. So Ranjit, the use case of Terraform is to deploy infrastructure on a particular cloud platform. It could be any infrastructure component. It could be network. So whatever you can do using the management console, you can do using Terraform. But why would you use Terraform when you are dealing with large infrastructures? For example, right now you just created one instance. You can create multiple instances as well. Okay, so let me show you how. So first, let's understand how do you read what you have deployed. So I don't want to go to the management console now. I want to know what is the IP address of my server. So I can just type in Terraform show. So with Terraform show, it will show me the infrastructure that it has deployed now. So this is the details of the infrastructure that I've just deployed. So my resource is deployed in US West 2C, right? This is the availability zone, right? And this is the public IP address of my instance. If I talk about the size of the volume of my instance is 8 GB. Okay. So now let me give you a very small example how you can basically use Terraform or why it's so popular among production environments. Let's say my manager comes and he says, you know what, my server is running slow. Can you change the volume size of my server from whatever it is right now to 100 GB? So I was like, okay, great, I can do that. So I don't have to go to my AWS management console and I don't have to learn the syntax as well. Okay, I'll just type in Terraform show. It will show me the current configuration of the server. And here I can see that this root block device is specifying the EBS details or the hard drive details of my instance. And here I see that the volume size is 8 GB. So what I'll do is let me just copy this. Let me come back to my code and I'll just paste this over here. And now I'll just delete what I want. So I do not create, I want this. Okay, I'll save this, come back to my terminal, I type Terraform apply. Now there are going to be some errors in this. Obviously there are going to be some errors because you cannot just copy and paste, right? So but if you read those errors, you will understand how to change your code. So here it says root block device dot zero device name, this field cannot be set. Okay, and then it says volume ID, this field cannot be set. So if I come back to my code, device name, I will have to remove this. So let's remove it. Then it says volume ID, then I can just remove this as well. Cool, save the code, come back to your code again, type in Terraform, apply. And now what it's going to do is, it's going to see what your current state of your instance is. And then it is just going to change the volume, or you can just see. So let it just load, and then I will show you what Terraform is going to change for you in the architecture. Okay. So Now this is the plan, Terraform plan. This is the Terraform plan that you see, right? So this is the icon that I was talking about. This is the icon that I was talking about. So this icon basically means update in place. Okay, so it's not going to delete your server, it's just going to update it, right? So what all is being changed? So first of all, I have changes in this resource, which is AWS instance example. Great. So everything over here, nothing is changing as there is no icon over here. What is changing? Only my EBS or my hard drive is changing, and in my hard drive only the volume size is changing. So right now this is the IP address of my EC2, it's going to remain the same. This is the network details of my EC2, it's going to remain the same. What is changing? Only the hardware size, only the hard drive of my instance is changing, and that to the size. Even the hard drive is going to be the same. So if I have some data on this hard drive, it's going to be the same. The only thing is the size is going to be different. So what I can do is, it's asking me, do I accept these changes? I say yes, I accept these changes. And now it is basically going to apply these changes to my instance. Now, obviously, not all these. So let's say I specify that I want to uh, probably change the availability zone. It is right now in 2C. I want to deploy it in US West 2B. In that case, obviously, the instance will have to be deleted and it will have to be redeployed. So not all the changes can be changed on the same server. Some changes will require your hardware to change. It is making the changes to my architecture. And once those changes are done, it will give me a success message over here. Darshan is saying this, there is not security issue while using Terraform. Well, Darshan, what I've just used here is, now what you can do is you can create a credential file in Terraform where you can have these access keys and the secret access. So in that case, relevant not able to these keys that you're using. Other way to use this would be, say, if you're using CLI, AWS CLI. So again, you can configure the AWS CLI, and again, the credentials will not be exposed. If you're using this on AWS, right? So in that case, you can just attach a role to your instance. And if you attach a role to your instance, again, your credentials are not exposed. But obviously, if production architectures are using Terraform, obviously the security is less assured fine over here. So, okay, so now as you can see, the message is apply complete, resources 0 added, 0 destroyed, and 1 changed. Okay, so here it also tells you that what has been deleted, what has been added, and what has been changed. And here you will notice that now the hard drive that is attached to this instance, it's basically your 100 GB volume, and it's not 8 GB anymore. Okay, Siva is saying, is it possible to do LVM on while creating instance on Terraform? I'm not sure what you mean by LVM, Siva. Can you go ahead and expand it? Okay, right. So we've just upgraded the server with 100 GB hard disk, and it just happened. So same happens. So in this code, I just specified one resource as of now. I can specify more resources. So what I can do is, let's say now I want to create one more resource, one more server I want to create. Let's call this resource as example2, right? This server I want it to be a medium server, and this time I want the volume ID to be 50 GB. Okay, so I'll just save this, come back to my terminal, I tell it to Terraform apply, and now you will notice it knows already that there is one server which has been created. So now what I'll do is it will just create a new server. Okay. If there are any errors, so there's going to be one error while I'm doing this, and it's going to show that error right now. So first it's going to show me the plan, and then it's going to ask me, do I agree to that plan or not? Okay. So as you can see, it says plan 1 to add, 1 to change, 0 to destroy. Okay. What is being added? So right now I have specified IOPS as 100, I think, over here in my code. Okay, so let me remove these IOPS. I don't want it to change it. So I'll just not agree to the plan, do enter value and no, and then I'll apply it again. So only my second instance will be created now. And you can see the other instance, it will not touch it. Okay, so here you can see that example 2 is being created and no other option is being shown over here. So example 1 or example resource or example instance is not even mentioned over here. Why? Because it's not going to touch it. Right? So if I enter yes over here, it will automatically deploy another EC2 machine for me. So likewise, if I mention multiple servers, it will create multiple servers. So it's just about mentioning it over here in the code. If I mention 500 servers, it will create 500 servers. Arvind, how can we ensure that only size alone is scaled up, but there is no data loss? Well, Arvind, that's because over here you could see that the volume ID, when I applied the previous configuration, you saw that volume ID was not changed. Can you see? The volume ID is not being changed. So if it's the same hard drive where where basically the size is increased. So if the hard drive is same, obviously there is no deletion of hard disk, which basically means that my data is being preserved. So that's basically an AWS feature rather than Terraform feature, that you can upgrade your hard drive size without losing your data. So right now, when I applied, so if I click yes over here, guys, it will create one more instance, but I don't want to do that. So I'll just hit enter. No. Okay. Let me come back to my code, and now let me show you. Somebody asked what about giving a name to your instance? So if you know AWS well, you will understand. So let me first type in Terraform plan. So you will understand that the name in an instance is basically a tag. Terraform show. So this will basically show you the current infrastructure which has been deployed. So you can see something called as tags over here, and there is nothing mentioned in tags. Okay. So all you have to do is you have to mention in tags the name of your instance, and then that would basically go ahead and apply it. For example, right now, if you talk about my instance name, there's no name. So this is the tag name. There is no name attached to it, right? So what I can do is I can just go to my code. I can in my resource of EC2, I can go ahead and create an argument called tags. And how will you know this argument basically is there? By reading the show configuration of your infrastructure. It says there are no tags specified over here, right? So I can just go to tags and then mention this inverted braces. And here I want to specify the name, right? So how will you specify the name? So when you're inside tags over here, you're not working with Terraform now. Now you're working with AWS. So here in tags, the key will go inside inverted braces, inverted commas, and similarly, the name will also go in inverted commas. So let's say this is Terraform hyphen instance. Save it. And now let me come back to my console. Here I will say Terraform plan. So now it will tell me if this is what I changed to my code, how is my infrastructure going to be impacted? So as you know, if I'm just changing the name, nothing should be changed. Instead of just the tag, instead of just the tag section, nothing will be changed in my instance. So that is exactly what will be showed over here as well. So it says 0 to add, 1 to change, and 0 to destroy. And what will be changed? I can just check the plan over here. So it changes, tag will be changed, and here this tag will be added, and nothing else is being changed, as you can see over here, right? So everything looks good. Just type in Terraform apply, and now what will happen is it will change the name. So I'll just type in yes, this is what I want to do. So it's modifying the instance, and as you can see, the instance has been modified. And now if you check in your management console, if I just refresh it, I think we mentioned, so I think I mentioned the key as wrong. So this has to be capital N if I'm not wrong. Let's check, because it's case sensitive when you are specifying the tags. Or let me just do a refresh from here. So the name has to be in capital. So I'll just click on apply again. Yes. So like I said, it's case sensitive. So now as you can see, the name has been changed to Terraform hyphen instance. Okay, so this is how you can put the names as well. So let's go ahead, guys, and now let's see how we can basically install a software on a particular server that we're trying to deploy. So when we deal with servers on AWS, there is something called as, so we can just check over here, there is an for user data, and if we are able to do that, we can mention that in. Okay, so we are not able to find user data over here. So what we can do is we can go to Terraform EC2 user data. So let's say I want to install, first I want to update the machine and I want to install, let's say Apache 2. So what I can do is I can create a sh file over here, and let me create it using Sublime itself. So in this Terraform folder, what I'll do is I'll create a new file and let's call it install.sh. And in this, let me write a script which is going to install the stuff. So I want to first update the machine, and then I want to install Apache 2, right? And then in my Terraform, what I'll have to do is I'll have to go to my Terraform file that I wrote, and then what I can do is I can mention user underscore data equals to, and then I can mention the file that I just wrote, right? In my case, it's install.sh. I'll have to mention it like this. Okay. So now what this is going to do for me is it's basically going to run this shell script for me on the server that is being deployed. Okay. Okay. So let's see what all things are getting deleted for us. So you're getting a sign like this. This sign basically means it will first be deleted and then it will be created again. Okay. So AWS instance must be replaced because of the changes that we have just told it to do, right? So it is going to keep the ARN, it is going to change the ARN, it is going to change the IP address as well, it is going to change the availability zone as well, CPU core count, this will be the same because we have mentioned t2.micro, right? So it is not changing, so this will also not change. It will change this setting, it will change this setting, it will change this setting, it will change the host ID, it will change the instance ID. Why? Because the instance ID is getting created again, right? So all these things will change, and user data only then will be added. Okay, and guys, this is why you cannot use it as a configuration management tool. Ramakrishna is saying, do not delete the VM, just install Apache. Well, Ramakrishna, if you're using it, doing it using Terraform, that is not possible. Okay, because the user data setting, it cannot be changed. So what is user data? Let me show it to you. So when you're dealing with this particular instance, if you go to actions, if you go to settings, and if you go to view or change user data, I cannot type anything here. It says to edit your instance user data, you need to first stop your instance, right? So if I want to add user data to this machine, it can only be added once I stop this machine, and user data only runs when your machine restarts. Okay. If I restart the machine, I lose the IP address, right? I lose a lot of things. I just lose the IP address. I do not lose the other things. But when you're using Terraform, as it knows, it's not used for configuration management. It knows that, right? So it finds it more easy to delete the hardware and redeploy it with the data that you want, right? So that's why if there are any software changes that you want to do, you do not have to use Terraform. Use configuration management instead, because in that case, it will not touch your hardware. It will only change the software that you want, right? So in what case would you want user data to be added to your servers? When you want your servers to have a pre-configured software once it's deployed. So now let's see what is going to happen. Okay. So I'll just do a Terraform apply. And now let's see whether it installs the Apache 2 software for us or not. Okay. So now I'll just type in yes. So now just have a look at the instance ID. Okay. Since it's being destroyed, it means it's being deleted, right? The new instance ID which is going to come up, it's going to change. So as you can see, it says destruction complete after 36 seconds. And now it is creating it. Also guys, in order to see if Apache 2 is working or not, what we'll have to do is in the security group, which will be basically used, I will have to open port 80. So we will just check. So it says apply complete, great. So if we refresh this, again, you can see the previous instance has been deleted and the new one has been created. And the new one is still getting initialized. Okay, so let's wait till it gets initialized. And what we can do is we can go to the security group, which is this, which is default. And I think in the default security group, although the inbound rules allow us, but let me just verify it if that is the case. So yes, everything is open. Cool. So I don't have to change anything here. And now let's just verify if we are able to see Apache 2. So if I go to this IP address, it refused to connect. It means it's still installing the software. So you can see the status is still initializing. So let's wait for it to initialize, and then it can basically show us the Apache 2 software. Okay, cool. So I think our website should be up. Okay, it's not up yet. Okay, let's try this. Let me go to my instance. This is the IP address. This is the code. Okay, it's not running. Let me just figure out why it's not running. Give me a moment. Okay, I think I've figured out the reason. So when you run this command, it basically asks you yes or no while you're running it, right? So let me give you a small example. So let me, I think I should have an Ubuntu container running. Let me show you by running an Ubuntu container and running that same command. So this is an Ubuntu operating system, okay? So if I run apt-get update, it will update it, right? It will take like 30 seconds to do it. And when I install Apache on it, you will see it asks me whether I want to, whether I confirm it, whether to install it or not. Okay. So apt-get install Apache 2. So can you see it's asking me, do you want to continue? So that's where the command is right now stuck. So in order to solve this, if you enter apt-get -y install Apache 2, it will run, it will not stop. And that is exactly what I will have to do. So let me just delete this container and then I'll show you how we can get it done. Okay, so coming back to the code, so I will have to add -y over here save it, come back to my Terraform plan. So even if I'm changing install.sh, you will see that it will be able to identify that there's a change in the shell script.
Just a quick info, guys. Test your knowledge of Terraform by answering this question. Which type of language is Terraform? A. Objective. B. Declarative. C. Descriptive. D. Functional. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So as you can see, it has understood that there is something to be changed because I changed the shell script file, right? So what I'll do is I'll just apply Terraform apply, and now it will do all those steps again for me. And the instance that I'm going to have now, it's going to have a part installed. Okay. Okay, so as you can see, Apache has now been installed on this new machine, that we basically just deployed. And guys, this is how you basically make use of Terraform to deploy any hardware.
How to crack AWS interview. So let's say, how do you do the preparation and how do you appear for the interview? Okay, so now as I say, the first thing is the hands-on and the services that I was talking about. For storage, you need to know S3, you need to know EBS, you need to know EFS, and remaining storage gateway on a high level, it's okay. Remaining, you don't have to focus so much. On the database side, Aurora, Elasticache, DynamoDB, and RDS. These four are very, very important. Remaining, you can skip. Okay. Security, identity, and compliance. AWS IAM is very important. Remaining, it's not needed that much. If you're from application background, AWS WAF, you can go through it, but don't dig deeper into it. Make sure you are very much comfortable with AWS IAM. Okay. All right. So cryptography PKI not needed at all. Machine learning not needed at all. And management and governance. Okay. So here there are few topics like auto scaling, very important. Cloud formation, very important. Cloud Trail, CloudWatch. CloudWatch is again, there's no concept. You just see how to monitor stuff. Cloud Trail is again very simple, not that complicated. Okay, CloudWatch, CLI for AWS admins, very, very important. Command line interface, you need to know that. AWS config is important. Okay, and remaining, it's not needed that much. You can go through AWS OpsWorks on a high level. Okay, in migration and transfer, go through database migration service, go through schema conversion tool on a high level. And on the networking and content delivery, CloudFront, you do not need to know CloudFront in detail, just know what it does. That should be enough. Okay, Route 53, very important. Elastic load balancing. AWS VPC, super important. These two, end user computing, front-end web service, not needed. Analytics, if you are from analytics background, if you are from database administration background, then analytics is important. So which other things you should know? Amazon Athena. But again, before this, you should know big data development, right? Amazon Athena is important. Cloud Search, data pipeline, Amazon EMR, Glue, Kinesis, and Redshift. So if you are from database administration, big data administration, or data warehousing backgrounds, then these are needed. If you are not, don't even bother. For application integration, Amazon SNS, SQS, very, very important. Just go through Amazon MQ and state functions, what it does. Again, on a high level of SWF. If you skip SWF, that is also fine. You don't have to bother about SWF. Business applications not needed. These are not needed. Yeah, satellite robotics, quantum computing, blockchain, AR/VR, these are not needed at all. Billing and cost management, go through it. Again, this is not for certification. This is needed for you to work on AWS. Management console, again, this is not a topic. You already know AWS management console. If you want to become an AWS developer, SDKs are very important. If you're from Java background, you should know AWS SDK for Java. If you're from Python background, you should know AWS SDK for Python. If you're from .NET background, you should know AWS SDK for .NET, so on and so forth. These are not needed, at least right now. Okay, so these are the important topics. Again, this is step number 2. So how do you broaden your experience on AWS? So that is step number 2. Okay, no one is going to ask you how do you launch an EC2 instance. No one is going to ask you how do you create a security group. People will ask you, let's say, how do you create what are the things that you have to take care of when you create a 3-tier architecture, when you create an application, or when you're creating a VPC for a 3-tier architecture. Okay, again, this is a simplified question. Again, the question would not be so simple. So for example, let's say the first question, you have an application. I hope you can see this. Let me increase the size. So you have an application deployed in AWS, but because of security reasons, all of them have been launched in private subnet. NAT gateway can't be used too. How do you get software repositories to those machines? Now, if I tell you the answer, so real-time questions, you cannot find those in documents, right? So these are the things that you can answer only on practice. Okay, all right. How do you get the IP address of an application load balancer? What do you see when you try to do so? Okay, how do you get the IP address of an application load balancer? NS lookup is the command. So again, this will not be asked in the interview. Okay, so the question here is that try NS lookup. So the answer for this one is bash and host. Go to the architecture of load balancer, and then you'll be able to understand why we'll see multiple IP addresses for the load balancer. Okay, all right. Question number 3. You have a retail application set up on AWS. Electronics section is in VPC 1 and home appliance section in VPC 2 in the same region. The payment component needs to communicate to both the mentioned sections. Where do you place those? Tell me the application design for the same. Okay, so this is an application design question. This actually, see, don't get too much nervous about this last line. Tell me the application design. Actually, they are not asking for application design. If you see, they're asking for the network topology. So one is in VPC 1, electronics is in VPC 1, home appliance is in VPC 2. The payment component needs to communicate to both the mentioned sections. Where do you place those? It's a network topology question. So if you know VPC well enough, you'll be able to answer this. So the answer is, can anybody try? 3-tier is not the answer, no. VPC 3 in the same region, exactly, VPC peering, correct. So you create another VPC where the payment gateway or the payment component would be placed. VPC 1 would be paired with VPC 3, and VPC 2 would also be paired with VPC 3. So see, this is not an application design. So even though the question says, tell me the application design for the same, the answer is actually a network topology. Correct? All right, design a disaster recovery system of an application with 2 hours of RPO and 12 hours of RTO. So what is RPO and RTO? This is there in the self-paced video. So if you know what is RPO and RTO, it will be very easy to answer this. Now, what is RPO? RPO is recovery point objective. Just let me give you a high level idea about this question. Now there is a very common question. Okay, you can get this question literally. This is one of the favorite questions of the interviewers. So RPO is recovery point objective, which means that the time, sorry, how much data can you afford to lose? So that's what RPO says. 2 hours means you can lose data for 2 hours. Okay, so that is point number 1. What is RTO? RTO means how long will it take to bring up the DR region. Okay, so application on the DR region. Okay, so now how do I answer this? So first is RPO. When we talk about RPO, you need to know what an RPO is. As I said, it is about just a second. So it is about the time that you can afford to lose data. So they are talking about data. And where do you place data? You place data in RDS databases. Correct. Now, there's an answer that you can deploy backup for every 2 hours. No, that is not feasible. What if your database size all combined is, let's say, 10 terabytes? Do you think you can take a backup of 10 terabytes in 2 hours? Not possible. What do you do? That answer has been discussed in the training. And the answer is read replica. So if you create a read replica, you get an RPO much lesser than 2 hours, because your replication lag is somewhere in seconds. So create a read replica of your database systems. Okay, what about application? How do you take backup of application? That is also covered. So application, you have AMIs, right? So what are AMIs? AMIs are the so basically you launch an EC2 instance, you install all your applications, you put your code in the EC2 instance, and then you create an AMI. And you can copy an AMI across to another region. So what do you do if it's 2 hours? Then application does not have any data. So on the application side, you just have to make sure that your AMIs are available in the DR region also. Okay. And on the DR region, then you launch the application just the way you launch on the primary side. Okay, question number 5. Even though you have set up auto scaling, new instances are not starting. What could be the reason? No, the workloads have reached its limits. Let's say one of the answers is it has reached its maximum limit. So let's say minimum in the auto scaling group, minimum number of EC2 instances is 2, and the maximum is, let's say, 5. It has already reached 5. Again, this is typically in a certification question, but it is asked in the interviews also. Okay, you have an S3 cross-region replication, but you see that the objects are not being replicated. What could be the possible reasons for the same? Think about it. What is connect metric? There's nothing called, correct metric or alarm not triggered. Alarm for what? Choosing of regions, permission issue, yes. So see, when you set up AWS cross-region replication, you don't have to do anything. No alarm is needed, no matrix is needed. S3 does it automatically, as long as the S3 service itself has an IAM role attached to it, which can put object in the other bucket in the other region. So this is a permission issue. So this is not, so as you can see, this is not an S3 question as such. This is mainly IAM. So if you practice enough cross-region replication.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
There's an option when you set up cross-region replication where it says create a role. So if you have not done hands-on, you'll never know that exists, right? So that's why hands-on is needed. Okay. Question number 7. Your organization has IBM DB2 databases installed on hundreds of EC2 instances. As they are not managed services, DBAs are needed to maintain and govern those databases. How do you allow DBAs in your corporate network to log into those DB2 database servers? Okay. IAM is not the answer. No, it's DB2 on EC2 instance. So you want DBS to on your corporate network to connect to a database which is on EC2 instance. How do you do that? SSH is the answer. Yes. So basically, what do you do? Through the internet, definitely no. So that is not the answer. So what you do? You create a, let's say, bastion host, SSH into the bastion host. And from bastion host, you SSH into the DB2 EC2 instances where DB2 data servers are installed. Okay. Again, as you can see, this is more on network topology again, because it talks about how to allow people from your network. So now, what about bastion host and your network? Now here, you need to know that, okay, the AWS VPC would be connected to on-premise data center either using VPN or using direct connect. That's all you need to know. Okay, so the interviewer might ask, how do you make sure that the connection is there between your AWS VPC and your on-premise data center? So you say, okay, you can use VPN or direct connect. Now, no one expects you to set up VPN or have experience in VPN setup or direct connect setup. But you should know, okay, these two can be used. Okay. Question number 8. You have an application like Instagram to upload your photos by users. Users take selfies using their mobile phones and upload those to the application. We are planning to host the application on AWS. How do you design such application? What AWS components would be needed? Now, see the question again. It talks about how do you plan to host the application on AWS? How do you design such application? This is not an application design question. Remember that. To read the question carefully, it says, users take selfies using their mobile phones and upload those to the application, which are hosted on AWS. What AWS components would be needed? So you can use either Lambda or EC2 instance. Now, the photos are uploaded by the application rather than the users directly. So the if the application on EC2 instance, either on Lambda, let's say that is on EC2 instance, Instagram Live application can be on EC2 or Lambda also. Now the question is, how do you upload the photo from EC2? How EC2 uploads the photo? See, the application is on EC2. It can be in Python, it can be Node.js, it can be Java. How do you upload that to S3? Now, again, here the question is about permission. So you need to have an IAM role attached to the EC2 instance, which will be used by the application to upload the photo in S3. So what AWS components would be needed? It would need S3, it would need AWS IAM, it would need AWS EC2 or AWS Lambda. Of course, auto scaling, load balancer, VPC, all those things are also there, which are implicit. You should tell those things implicit from my side. Okay. Question number 9. The global application is hosted on AWS and its database is placed on RDS. Now the problem is that the number of users is increasing and you are getting performance issues ever since. What are the troubleshooting steps and how can you solve the problem? Mention the steps. So the troubleshooting steps is typically for the database administrators. This is not for AWS architects, but how do you solve the problem of the performance issue? So monitor CPU usage again. Why do you need to monitor? Because you already know that there's a problem. Monitoring CPU usage will not help you solve the problem. It will tell you that there is a problem. Auto scaling, you cannot do auto scaling on RDS. RDS is vertically scaled. You cannot scale it horizontally. So what would be the solution? Think about it. Again, the situation or the service has been discussed in the training. How to use load balancers? So if you use load balancers, load balancers would be for application, not for database. So read replica is the answer, which can be used to scale. What about writes? Anything else? Okay, so can't you use SQS for this as a shock absorber in between the application and the database? So use SQS, and SQS can scale unlimitedly. You do not need to bother about SQS scaling. What do? You put the applications there, use it as queue, and then use applications and ask those applications to load the data on the databases at its own pace, which is comfortable for the database. So as I was saying, so can't you do that? So these are the things that you have to see. As I said, you have to know to use those, all the services collectively as an architect. That is the role of an architect. Okay. Storage auto-scaling will not help solve your purpose. Storage is for storage. How does it solve the problem of user? Right? Okay. Now, question number 10. You are working for a customer which has AWS resources. For security reason, customer is not willing to create AWS account for vendors. How to get access to the customer's AWS account in such scenario? So let me rephrase the question if you have not understood it. So let's say I am a customer and you are working for me. I don't want to create an account for you I don't want to create a user in my account. Okay, but you have an AWS account and you want to work for me. How do you do that? I don't want to create any IAM user in my AWS account. So how do I enable you to use my AWS resources? Because that is needed, because it'll be, let's say you're a service provider. For me, how do you do that? IAM is high level answer. What is AWS organization is not the answer. The purpose of AWS organization is completely different than what I'm saying here. See, you are a service company. I'm a product company, let's say. You need to know the usage of the services. Okay, so if you don't know the usage, again, how do you know the usage enough? You need to practice rigorously. You need to face a lot of issues, a lot of errors. Then only you'll be able to learn. Okay. So that's all.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session. So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.